What's going on, everybody? Welcome back to the channel. We have this interesting question that says, find the values of x that satisfy the square root of x plus the square root of negative x equal to 2. Now, take a good look at this equation. You notice that this first term, which is this first term, can only be a regular number when the value of x is either 0 or positive. While this second term can only be a regular number when the value of x is either 0 or negative. So we need one value of x that satisfies these rules. And the only value of x that we can say maybe, yes, satisfy these rules is 0, because the number that is both positive or 0 and negative or 0 is 0, right? Very good. So let's try 0 to see if we're going to be having 2 as the answer. So we have the square root of 0. We're trying for x equal to 0, by the way. So plus the square root of negative 0. So would this be 2? And the square root of 0 is 0 plus the square root of negative 0 is still 0. Now you see that the addition of these zeros gives 0, and this is not equal to 2. So there is no real solution to this question. That means we're going to be finding just a complex solution to this question. So finding a complex solution, we have to take the square of both sides. So we have the square root of x plus the square root of negative x to be equal to 2. So I'm going to be taking the square of the left. I'll also take the square of the right. Now, taking the square of the left, we have the square root of x raised to power 2 plus 2 times the square root of x times negative x, and then plus the square root of negative x raised to power 2. That is for the left hand side. So this is equal to the right hand side. 2 squared is 4. Now simplifying the left hand side, square cancels out square root. So we have x plus, now this simplifies into 2 times the square root of x times negative x is negative x squared. Very good. And then plus, now this square cancels out the square root, so we are left with negative x. And this is equal to 4. Good. Now x plus minus x is 0. So that is gone. So we are left with 2 times the square root of negative x squared. And this is equal to 4. Good. Now from here, we can just divide both sides by 2. So on the left, we have 2 times the square root of negative x squared equal to 4 on the right. So we divide both sides by 2. Notice that these 2 can cancel out, leaving behind the square root of negative x squared on the left-hand side to be equal to 4 divided by 2 is 2. Good. Now to get rid of this square root, we take the square of both sides. So I'll take the square of the left, take the square of the right. Now notice that this square cancels out the square root, leaving behind negative x squared to be equal to 4 squared is 4. Good. And since the unknown is carrying negative, all we have to do is to multiply both sides by negative. So that makes the left hand side to be positive x squared and makes the right hand side to be negative 4 when we multiply both sides by negative. Now we're close to our answer. So the next thing we're going to be doing will be to take the square root of both sides. So take the square root of the left hand side equal to plus or minus, take the square root of negative 4. Now see that the square root and the square cancels out, leaving behind x to be equal to plus or minus the square root of negative 4. Mind you, this negative indicates a complex value known as I. And then the square root of 4 gives 2. Good. So this is our final answer. So the value of x is equal to plus or minus I2. Or you can write it as plus or minus 2i. They are still the same thing. Let's check. So let's check. So on checking, we have the values of x. Remember our solutions, we have 2i and we have x as well to be negative 2i. So we're going to be trying this first. So using the complex number calculation, we're going to have when x is equal to 2i, you notice that the square root of x, which is this, will be square root of 2i. So from complex number, this is 1 plus I. So from this other term, we have the square root of negative 2i. So this will be from complex number, this is 1 minus I. So let's substitute this into our original expression. So from this, we have 1 plus I, so 1 plus I, that is it, plus this, we have 1 minus I. So are we going to be having 2 as a result? Now, let's face it, 1 plus 1 is 2, and 1, this is I minus I is 0. So we see that the left-hand side and the right-hand side are actually equal. So this solution is actually correct. Now, what about this? When x is equal to negative 2i. So when x is equal to negative 2i, that means the square root is still going to be the same. 2i, that means this will be negative 2i, which we all know from complex calculation to be 1 minus I. Then for this, the square root of negative 2i makes it positive 2i, which is 1 plus I. Now let's put this into our original equation. So the square root of x is 1 plus I plus the square root of negative x, which is this, is 1 minus I. Am I going to be having 2? Now let's add up. 1 plus 1 is 2. I minus I is gone. So we see that the left-hand side is equal to the right-hand side. And there you have it. So the values of x, which is equal to plus or minus 2i, is actually correct. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.